But how many photon? How many photon absorbed? One. Therefore, quantum yield is 2. This is because only the photon, not only the photon, but also one of the reactant also initiated the reaction. Okay? Yes. Not only this photon absorbed and molecule break away, but one of the products, break products, this should be like this. It half H2. It should be half H2 by I2. But this is not the case. One of these products again reacted with another molecule. Yes. Therefore, the quantum yield is greater than 1. The quantum yield will be greater than 1 if there is chain reaction. If there is chain reaction. Or propagation step, or propagation steps. Therefore, quantum yield will be greater than 1 if there is chain reaction or propagation step. Now, why quantum yield is less than 1? Quantum yield is less than 1. Less than 1. Because, suppose a case, you have a molecule AB plus HU. It gives AB star. This AB star deactivated to AB plus HU. Suppose you have 100 this, you got 100. 50 deactivated. And the other 50 gives A plus B. Okay, therefore 100 molecule, you have 100 photon. Okay, therefore in this reaction, only 50 is reacted. 50 is reacted. Only 50 is reacted. But how many absorbed? 100. Therefore 0.5. 100 absorbed, but quantum yield is number of moles reacted. Only 50% is reacted. Half mole is reacted. Okay. Therefore, quantum yield is less than 1 if there is any deactivation process happens. Okay. Now, application of quantum yield. Application of quantum yield. Let us discuss what are the applications of quantum yield. Let me check the video. Okay. Applications of quantum yield. First is, what is the quantum yield? One is number of moles reacted or produced divided by number of Einstein absorbed or number of moles of photons absorbed. Now, for first application, helpful to determine concentration of reactants or products, determination of amount of light absorbed. It also helpful the wavelength of light absorbed, the wavelength or frequency or wave number of light absorbed during the reaction. Okay. Now these are some applications of quantum yield. Now we can solve some numericals from this side. Okay. Very important. Students, let us do some numericals. Okay, let us radiation of lambda 2500 angstrom was passed through, let me check that, yes, through a cell containing 10 ml of solution of 0.5 molar oxalic acid and 0.01 molar uranyl sulfate after absorbance of 80 joules of radiation energy, light energy, the concentration of oxalic acid was reduced to 0.04 molar. Calculate the quantum yield of the reaction oxalic acid. Radiation of lambda 2500 angstrom was passed through a cell. That is, you have a glass cell means cuvette where you have oxalic acid plus uranyl sulfate. Uranyl sulfate is a molecule which is helpful for photochemical decomposition of oxalic acid. That is oxalic acid decomposition. For oxalic acid decomposition, we will mix some uranyl sulfate. Okay. To that, you give a wavelength of light to 2500 angstrom. And initial concentration was 0.5 molar. After 80 joule of energy absorbed. Now 0.5. Now it is 0.4 molar. 0.4 molar. Okay. 0.4 molar. Yes. 0.0. Okay. Let us make a 0.05. 0.05 molar and 0.04 molar. 0.04 molar. What is the quantum yield? The quantum yield is equal to number of moles of oxalic acid reacted or decomposed divided by number of Einstein. Let us discuss what is the number of moles of oxalic acid reacted. Therefore, molarity of oxalic acid reacted is 0.01. This much molarity is reacted. Therefore, 0.01 divided by number of moles divided by volume 10 ml, 10 into 1000. Therefore, number of moles of oxalic acid reacted is 10 raised to minus 2 into 10 divided by 10 raised to 3. Okay. That is 10 raised to minus 4. 10 raised to minus 4 moles. This much moles of oxalic acid reacted. Now we want to calculate what is the number of Einstein. Number of Einstein. 1 Einstein is equal to 6.022 into 10 raised to 23 into hc by lambda. That is 6.022 into 10 raised to 23 into 6.6 into 10 raised to minus 34 into 3 into 10 raised to 8 meter, all divided by, what is lambda? 25 into 10 raised to Armstrong, minus 10. Okay. Well, now you will get 12 into 10 raised to 8 divided by 2500. Okay, you will get this. This is Einstein. Now number of Einstein. Total 80 joule is absorbed. Therefore, this is this much joule. Okay. This is the energy for 1 mole. 1 mole. Therefore, number of Einstein is equal to number of Einstein equation is number of light energy absorbed divided by number of light energy absorbed, amount of light absorbed. Okay, then energy of 1 Einstein, energy of 1 Einstein. That is number of Einstein. Energy of 1 Einstein. Energy of light absorbed. What is that? 80 divided by 12 into 10 raised to 8 into 20. Yes. Okay. This is when you will get 1.6 into 10 raised to minus 4. Therefore, you got this one. Now we can go to the quantum yield calculations. Now, what is a quantum yield calculation? Number of moles of reactor. What is that? Number of moles of reactor is 10 raised to minus 4. Number of Einstein is 1.6 into 10 raised to minus 4. That is 1.6. You please do the calculation carefully. This is how you calculate the quantum yield. Okay. Now we can go to next question. Then we go to another question. Let me check the video. Okay. Calculate the number of moles of gas produced. Calculate the number of moles of gas produced by the absorbance of 1 joule of radiant energy of wavelengths 480 nanometer. Number of moles of gas produced. Okay. In the reaction, H2 plus Cl2 gives to HCl. Quantum yield is equal to 10 raised to 6. Mentioned very high quantum yield. How many moles of gas produced? Number of moles of gas produced. Quantum yield, therefore, in terms of production, number of moles of products divided by number of Einstein. You want to calculate this one. Therefore, first you got the quantum yield, number of Einstein. is equal to okay, number of and joules of light absorbed or energy of light absorbed divided by value of 1 Einstein. Value of 1 Einstein. Let us calculate what is 1 Einstein first. 6.022 into 10 raised to 23 into 6.6 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by nanometer 480 into 10 raised to minus nanometer. Okay. This is 2.5 into 10 raised to minus 10 raised to 5. Please do yourself. Do the calculation correctly. I just solve quickly. Now, what is number of Einstein? Number of joules of light absorbed. That is here one. Calculate the number of moles of gas produced by the absorbance of 1 mole joule of radiant energy, or 1 mole. Therefore, 1 mole is absorbed. 1 divided by 2.5 into 10 raised to 5. Therefore, number of Einstein is 4 into 10 raised to minus 6. 4 into 10 raised to minus 6. 4 into 10 raised to minus or 4.4 into 10 raised to minus 5. 4 into 10 raised to minus 6. Now, we can calculate the number of moles. The quantum yield is given. Quantum yield is 10 raised to 6 is equal to number of moles of products divided by 4 into 10 raised to minus 5. Therefore, when you cross multiply, what do you get? Yes, you will get the answer. Okay, 40 moles answer. Yes, that is 4 into 10 raised to minus 5 into 10 raised to minus 6. That is 40 moles answer. Yes. Here 10 raised to minus 6. Therefore 4. I'm sorry. 4. Here 10 raised to minus 6. Sorry. Therefore 4 mole is the answer. Okay. Okay. Thank you for watching. If you have any doubts, you can discuss it. Thank you.